Hey everyone, here's a video on graphing linear inequalities. So we started this a little bit by graphing linear equations, and now we're going to move on to graphing linear inequalities. So just remember, they're going to be graphed just like anything on a slope-intercept form. The only difference is we have two types of lines. We have dashed lines and solid lines, and then we have to shade either above or below. So here are sort of the facts of linear inequalities. You have a dashed line whenever it's y is greater than or y is less than. So whenever you have something that's just a less than or greater than, it's a dashed line. Sort of like if you had like x is greater than 3, you put an open circle and then shade with your arrow. You have a solid line when you have y is greater than or equal to or y is less than or equal to. Sort of like if you had x is greater than or equal to 2, you go to 2 and you have a closed circle and then you shade from there. So remember, if you have the line underneath, it's or equal to, and that means it gets a solid line. If it doesn't have a line underneath, it's a dashed line. The other rule you have to remember is shade below or shade above. Shading below is when y is less than or y is less than or equal to, because you're looking for all coordinates that are less than or equal to your inequality. Basically, it's anything that satisfies the inequality being less than or equal to. You shade above the line when you have a greater than or equal to. So if you shade below, it's going to look something like this. If you shade above, it's going to look something like this. And that's when you have a greater than or equal to. So let's try some examples. Y is less than 1/3 x plus 2. So like I said, we graph just like we're in slope-intercept. Go up to 2. These are slope, which is up 1, right 3, or down 1, left 3. Now this is less than. So if we go back to our last page, we see that it's just a less than, so we get a dashed line. And since it's less than, that also means that we shade below. So below this line, we're going to shade in everything. That's all the points, and that goes on forever and ever, down, 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 because any point in this shaded region, up until this line, would qualify as a point that would work. Any of these points, if you plug it into your equation or your inequality, would hold true. Anything above it would be false. And in this case, since it's a dashed line, anything on the line would also be false because it's not included as a part of your inequality. It's not part of the solution set. Everything that's shaded is. How about this one? Y is greater than or equal to x minus 3. Go down to -3. Slope is 1, so we go 1 over 1. Up 1, right 1, down 1, left 1. Greater than or equal to means we have a solid line, and greater than or equal to means shade above. So we're going to draw a solid line. Make sure that in these, your line goes all the way from the start of the graph to the end of the graph. Okay, don't let it cut off early, or else your shading is going to be inaccurate. And since it's greater than, we need to shade above the line. So this is any part of the graph up here. The difference with this one is that since we have a solid line, beyond the shaded region being a solution, anything on the line is, because it's included. If it's a solid line, the points are included, and they are part of the solution set. Whereas when it's a dashed line, they are not included and not part of the solution set. Y is greater than 3. So in this one, we know we go up to 3, draw a horizontal line, which in this case is dashed because it's just greater than. There's no or equal to. And we want all numbers greater than 3. So we look at our graph and we see numbers that are greater than 3. Well, 4 is greater than 3, 5 is, 2 is not. So let's shade all the numbers where y is greater than 3. Any of those points would work. At any of these points, if you look at it, the y value is going to be greater than 3. Just giving a couple examples of points. where you see the y value being greater than 3. So if you were to plug that in, you would say 9 greater than 3, or 4 greater than 3. Notice how this is a dashed line, and at this point would not work because 3 is not greater than 3. So anything on the dashed line does not work as part of your solution set. Anything above it will, though. X less than negative 4. So we'll go over to negative 4. And since it's an x, we have to draw a vertical line. So we'll draw a vertical line at negative 4. We're looking for x values that are less than negative 4. So that would be something like negative 5, negative 6, negative 7. So we want to shade over this way. Again, since we have a dashed line, points like this, negative 4 won't work because our x value, negative 4, is not less than 4. That's not true. But if we picked a point like this, negative 9, 0, negative 9 is less than negative 4. So that's a good way to confirm it. Once you've shaded, check a point. A couple more examples. X plus 4y is less than or equal to 8. So I told you in class today, if you start with standard form, you need to go to slope intercept. We go from standard to slope intercept because if we don't, we might miss dividing by a negative, and we might miss flipping our inequality. So let's subtract x because we want to get y alone. That's our goal here, to get y alone. So we have 4y less than or equal to negative x plus 8. Divide by 4. Y less than or equal to negative 1/4 x plus 2. In this case, we didn't have to flip the sign because 4 is positive that we divided by. All we had to do was solve for y. So we go to 2, and then we use our slope, which is down 1, right 4, or up 1, left 4. And it's greater than or equal, or less than or equal to, so it's a solid line. And then we need to, since it's less than, shade below. So this is a solid line, so any point on that line would work. And let me prove that to you. Say I pick the point 0, 2. First off, you know it's going to work because it's your y-intercept, but let's prove it. And it's a solid line. So we have 2 less than or equal to negative 1/4 times 0 plus 2. Negative 1/4 times 0 we know is 0. 2 less than or equal to 2. If it were just less than, that wouldn't work, but since it gives us the option of or equal to, we're good, and it works. So one more example before this is all done. 3x minus 3y is greater than 6. Solving the slope intercept by subtracting 3x. Negative 3y greater than negative 3x plus 6. So we see an issue here. We have a negative before the y term, which means we need to divide by a negative number, which is going to cause us to flip our inequality. So divide negative 3 to everything, y. Flip the sign now since we multiplied by a negative. Is less than 1x, so we just put x, minus 2. So now we can graph this. Go down to negative 2, go up 1, right 1, down 1, left 1, and it's just less than, so we want to put a dashed line and shade below. Great. And that's it.